Welcome to Math That Matters, right? This is our first lecture, so we're excited. And Pete and I, we couldn't think of a better way to get started in Math That Matters than just to do some math.
It'll be fun. It's always been fun.
But math that matters only, right? and math that matters means real life problems. So we're going to start with a very real life problem, and it's actually something that happened to me. Pete knows about this, but I got a letter. I got a letter from American Express. All right, take a quick look at it there. And it was pretty exciting, I got to tell you. It says that I may have won the American Express sweepstakes. This is
That's
true.
really exciting.
Yeah.
I've gotten one of those before.
No,
Actually, like 10
yeah,
of them,
and it's $1 million sweepstakes. And they said, Neal, we think you might win this thing, so I need to get prepared. And I got two options. They said, we want to know if you win this, would you prefer to get your award as $475,000 as a single one-time lump sum? Or as an alternative, we'll give you $33,333.33 every single year for 30 years.
I thought they said that we were winning $1 million. That neither of those looks like $1 million.
Well, that one actually, if you multiply that out, that is $1 million, Pete.
So you mean I can either get $1 million or not $1 million?
Yeah, and I got to choose. So I
think this.
Yeah,
I want $1
you can
million.
see I did a bunch of math. I did a bunch of work. I got so excited. I started calculating this out. So I got to get prepared. So I think right now we want to pause this video and we want you to answer this question. This is something we'll do regularly through the semester. We're going to pause and ask you to think. All right, this is your first chance at answer a question. So which of these would you choose and why? Take a second to figure that out. So what'd you decide? Pete, let me ask you. I don't want to ask what the answer is. What do you think most students decided and why?
Well, it seems like this is $1 million and this is less than $500,000. So wouldn't we all want that?
I'm guessing most of you decided that. And Pete and I have done this over the years. And I think last year, every single student in the class chose that one, right?
Probably.
If I remember right. Yeah. We're not going to tell you what the right answer is. And by the way, there is a right answer. And the reason you know there's a right answer, the right answer is the one that American Express hopes you don't pick. Does that make sense? The right answer for you is the wrong answer for them. And American Express is praying that we pick which one, Pete, for their sake. What do they want us to choose?
Well, I think they want us to choose more money.
They do, yeah. Because they know that this is going to cost them even more money.
Yeah.
All right. We're gonna go into this later, and we're gonna explain why there is a right answer. But today we want to take a second and unpack this problem more conceptually and talk about the lessons that it teaches us about mathematics. The first lesson is that money without the concept of interest is not really true, is it, Pete?
It's not.
It's ignorant, no offense, but it's ignorant, and it's also irrelevant.
Yeah, and we have to understand that money can actually work for you or it can work against you.
That's right. Because the real question here is when you add the interest in here, how much do you have? And when you add the interest in here, how much do you have? We have to compare these two to get the right answer, not these two. Okay? So that's lesson number one, is that money without interest is not real. We want to understand interest.
Makes me wonder, like, I don't even know what you mean. Does interest, is that like when I saw my wife for the first time?
That was definitely an interesting moment.
Okay, so I'm going to learn something about that then.
And we're going to talk about that. We're going to talk about what interest means in our upcoming lecture, okay? Lesson number two is that financial problems are often simplified by a formula. And there's a couple formulas that make this problem much more manageable. Let's talk about them. The bottom line that Pete and I want to share with you today is that knowledge is power. And in financial mathematics, that knowledge usually has to do with formulas, right? Not a bunch of them, just a few of them. But here's a couple formulas that actually help explain why one of these options is substantially better for you and substantially worse for American Express. We're not going to solve them today, but upcoming in the next few classes, we're going to unpack these so you understand them. What we want you to do now is we want you to pause the video again and to do some thinking, but this time we're adding an exercise into it. This is your first BLQ exercise, big lecture question exercise. And we want you to pause and think how these two formulas might apply to these two financial scenarios. We know you don't know anything yet, but just take a guess. What do the different variables stand for? How might you use them? Which formula applies to which scenario? And how together could these formulas help us solve the mystery of this puzzle of finding a better solution?
Yeah, and I think in life, a lot of times we don't realize the consequences of things, or there aren't any consequences, but if this were life and death, and you knew that these two formulas could answer these two questions, and life and death was on the line, you might try some things, and that's what we want you to do.
That's right. And just for fun, I'll tell you, we did a couple calculations. It depends on the interest rate, again, because interest is everything. But depending on the interest rate, one of these options could be worth $5 or $10 million more than the other one. This is not a matter of $1 million or $500,000. This is a matter of $5 million versus $10 million, or maybe even $15 million. But the only way to understand that is to understand these formulas,
Now
which
I'm
we're going to
more
get into.
excited.
Yeah, I know they're excited. Okay, on to example number 2. Okay, well, for example number 2, we told you these were real life scenarios, and the last one was, as you saw, this one, I don't think it's that real life.
Yeah, I don't know how likely it is.
Yeah,
but
it depends about your
somebody.
family. This is about the story where you have an eccentric aunt, and she happens to be pretty wealthy, and she's hiring you for a little bit of work in the summer. Not a long-term contract, it's a couple weeks or something work. And she gives you 2 options for your salary. You can either get $1,000 a day, so again, it's a good aunt. This is a good aunt to have, right? Or she offers you 1 penny on day 1 with the salary doubling every single day after that. And she asks you at the outset, you need to choose one of the salary options, okay? Before we ask you to think which option you're going to choose, you should have a question for us. Pete, what is the question that they have to ask before they can decide?
Well, I mean, I want to know what's the better deal, but I think I'm missing information, aren't
Yeah,
I? Like,
yeah.
how long am I going to work? Because if I work 1 day and I get $1,000,
That's better.
or 1 penny, then yeah, give me the
Yeah.
day.
Okay, let's say 10 days. Let's say it's going to be a 10-day
10
contract.
days, but
yeah.
each day I get $1,000.
Yeah. What do you think? What do you guys think? For 10 days, which of these would you
That's
choose?
pretty
is this
easy.
is this easy?
That's a high school no, that's a grade school question.
Okay.
$10,000.
Okay, yeah, this
10
is the
days.
option, right?
So I can have $10,000 in 10 days, or I can have, well, let's see, a penny
We can do
times
this.
2 is 2 pennies,
Got it?
times 2 is 4 pennies,
Got it?
times 2 is 8 pennies,
Yeah.
and then 16 pennies, and then 32 pennies, and 64, $1.28,
Two more.
$2.56.
$5.12. $5.12 is your salary on day 10.
$5
Oh, no, but you got to add it up. So it's a total of $10
A
or so.
total of $10.
Total of $10.
Okay,
About. Okay.
approximately.
By the way, I'm guessing that there's some of you that may have chosen this one because you were taught in high school they're trying to trick me. And if they're trying to trick me, I always choose the opposite of my intuition. Don't do that. Just think. This is a thinking class. And if you think, you'd be a fool to choose this over this, right? Okay. But what if we go to 20 or 30 days? 20 days or 30 days. And at this point, we're going to pause and ask you to think. If it was a 20 or a 30-day agreement, which of these options would you choose and why? Take a second, figure it out. Okay, we're back and Pete is filling out our table. This column's pretty easy, right? Pete, if it's a 20-day contract, it's $20,000. Let's go over here for a second.
Yeah.
I did a little work. It took me a while, but I added up all these days and I actually got $10,000.
Oh, wow.
Total.
So we're catching up.
Yeah, we're catching up, but still, if it's a 20-day contract, you need to stick with the $1,000 a day. If not, you're going to lose $10,000, okay? But you know what happens when it goes to 30 days? Clearly, this is $30,000. This is the number that will surprise you. Can you just take a guess before we fill it in? Is the 10,000 going to go to 100,000? I don't know what. Well, Pete, do you have a guess?
I do, but it's not fair. I've done this problem before.
Okay. It's $10 million.
And these are approximations, right?
Yeah.
We're rounding.
It's interesting what's happening. From 0 to 10 days, it goes up to $10. Then the next 10 days, I go from 10 to 100,000. That's 1,000 times more. But then from day 20 to 30, I don't increase by 1,000. I increase by 100,000, which is just really crazy, right? The lessons in this are, number one, if your aunt offers to pay you a penny a day, take it and work as long as you can for her, okay?
And
For
even
sure.
if she doesn't, I'd go to work for her.
Yeah, I'll take that deal too, right? But just like the last problem, there are magic formulas. These are a little interesting. The formula over here on this side is very simply that your total is equal to your pay times the number of days. It's a pretty simple formula. That's how Pete filled out that column. Over here, it's a little bit more interesting. And your total is equal to the pay times the number 2 to the nth power minus 1 all over 2. And you'll find if you put the number 20 in there, you get about $10,000. Or if you put the number 30, you get about $10 million. And this is another chance for you to do a little exercise. We want you to pause, and we want you to do your BLQ exercise, which is I want you to find what's going to happen at 40 days. Okay? This one we hope you can get pretty quickly. This one you're going to need the formula. Try to use the formula and take a guess, first of all, where's this going to go? And it might surprise you. But again, the lesson here, Pete, is that the formulas can take a pretty complex situation and simplify them, right?
Yeah, very helpful.
That is, if you know how to use the formulas. And we'll talk more about that coming up. The second lesson in this exercise is the lesson of compound interest. You're going to hear that over and over from us over the next several weeks. But compound interest, this is not exactly a compound interest problem, is it, Pete?
It's got compound interest embedded in
Good.
another complexity.
Yeah, so it's not a true financial scenario, maybe, compound interest, but it does have compound interest in it. Yeah. And what you're seeing here is the power of compound interest. You're seeing how dramatic it can be. I want to show you one more example that we're not going to work through, but just how powerful compound interest is. Just a super quick illustration of the power of compound interest here. Suppose someone took $1,000, a young college student, and they invested it for 50 years into an account. And they have 3 different options. One is they can take it home and put it in their safe. Okay, if you put it in your safe, how much are you going to have at the end of 50 years, Pete?
$1,000.
Yeah.
It's safe.
That's it. You got it, okay? No interest. But you could also invest it at 9% simple interest. And at the end of 50 years, Pete, what are you going to have?
$5,500.
Right, which is, what's that made up of?
That's made up of the $1,000 that you gave to the bank or someone else.
Good.
And they got to keep it right then for 50 years. And
That's
then
right.
at the end of 50 years, they give you some interest.
A lot of interest, $4,500 interest.
Yeah.
Okay.
Seems like a good
Or
deal.
you can also go to a different bank and put it in for the exact same interest rate. It's not a bigger interest rate, it's 9%. But you're going to get compound interest instead of simple interest. And this is shocking. You would have how much, Pete?
$88,000.
So how much interest?
Minus $1,000 is $87,000 of interest.
The
So
bank-
you made $87,000 in 50 years.
Wow, that was really nice of the bank, wasn't it?
They must love me.
Yeah, and this is a real life scenario that's showing the power of compound interest. Most people think that the most dramatic jump is to go from no interest to simple interest. That is dramatic, and that's cool, especially if you're a poor college student. But that's not very cool compared to this jump. The real jump is to go from simple to compound interest, which is why we're going to spend time next class unpacking compound interest.
All right, good. Well, a couple of things that you're going to need, a couple of skills that you probably learned in high school, but I'm going to remind you of, are how to deal with percents and decimals, and then how to work with formulas. So you'll need this on your homework. I figured I'd give you a little refresher here. Just one reminder is a percent is a part of something. And so whenever you have a percent, it's also referring to not just that number, but some amount that you're taking a part of. So if I have 25% of something, I'm taking a quarter of that amount that I have. And you need to remember that 25% can be represented as a decimal at 0.25.
You
It
know,
really means 25 out of 100.
I learned, Pete, that percent means per centum in Latin.
Per centum.
Yeah,
Per 100, right?
I guess so. I don't know. I wanted to
centum.
say Latin, so I said
I
per
know.
centum.
Yeah, you sound a lot smarter now. That's good. Yeah, so just remember that if I have 25%, essentially it's 25.0%. And if I want to get rid of this percentage sign, I just move this 2 places to the left. And so you see no percentage sign and the decimal point. If I had like 4.7,
Up here I got 4.5%.
let's
for
try
example.
4.5%. So
Yeah.
if I'm going to enter this into a formula, I can't enter 4.5. It's not going to work. It's not what
It
the
is
formula
4.5, Pete.
Well, it is 4.5, or it's let's see.
Oh, okay.
0.0045. And so,
Oops, you went one too far. Sorry.
oh, look at that.
I think, right? Yeah.
Are you sure?
Well, I don't trust me, but
Should this be an outtake?
yeah, I don't know.
No, it's 0.045. I can't count.
That was
I'm a
right.
math teacher.
I was just using your bubbles, so that's why I got it right.
I appreciate it. It won't be the last time I make a mistake, even on camera.
Or the students won't
yeah, and they
either.
may even record it and
that's
put it
all
on
right.
the video.
We're
But that's
real.
okay.
Yeah.
It's
Keeping it real.
pride goes before a fall, right?
Yeah.
Yeah. So you've done this before. We want to, when we enter percents into formulas, make sure that we enter them as decimals.
And we're going to have a percent in every single math problem financially.
Yeah. And so this is a math problem. I don't even know what this math problem is about, but there's a formula here that kind of looks like something you put on the board earlier.
Yeah.
And now what I see is a whole bunch of letters. In fact, I see R over N a lot. That seems to show up a lot in our formulas, and we'll talk about that later. But now you've got some inputs over here. We're actually going to put numbers into letters spots, but the one letter that you don't have a number for is A, right?
Is it always the one that's over there?
Well, no, that's the problem,
Okay,
right?
all
So, but if the thing that you don't know is all by itself, that means the formula is solved for that letter. And so thanks for that.
Yeah.
Neal gave me an easy problem. So what I need to do is to find the unknown given these inputs is I need to just put those numbers into their proper place. And then I need to punch buttons on my calculator, right?
Yeah.
Yeah, so let's just do
do a
that.
sample
Go
here.
ahead. So we have A, which is something, but we don't know what it is, and that's okay. For right now, A is going to be 15 times, remember parentheses mean times, 1 plus R is 4.5%, so I'm going to change that to a decimal.
Oh, that was tricky.
Over N is 52, that's okay. And I have to take that to the 520th power, subtract 1, and divide by 0.045 over 52. That just seems like a lot of work.
I noticed, Pete, they gave us a T, but there's no T over there.
Oh, shoot.
You don't have to use all these. It's okay.
Yeah, so it's
If
a
there's-
distractor.
If there's no T, it was just a decoy.
A decoy is
That was
not a very
nasty.
nice thing to
I'm
do.
sorry,
Yeah,
that was tricky.
Appreciate that.
But you passed the test. You didn't
Yeah.
use it. I thought you might just slip an 8 in somewhere just because.
Yeah. Now, when you were using your little tiny calculator back in high school, you might have thought this is going to take a while. And maybe you did like 0.045 divided by 52. You sort of found a number for that. And then maybe you did that number here. And then like in steps, you might have been taught to just type things into your calculator and get little pieces of this done. My encouragement is to do it all at once. But
Let's
you have
go
to
for
learn
it.
how to do that. And to do that, you have to remember that parentheses mean times. And there's a way that you can type this whole thing into your calculator and then just push equals. And it will do it all for you.
I
As
don't
long
have
as
to,
you
I don't have to write the
parentheses
little
buttons.
numbers here and there and do it in steps.
You don't have to.
All
And
right.
in fact, if you do it in little steps and you round off and you round, if you take something that's rounded off to the 520th power, imagine what your rounding
gonna
error is
screw the
gonna
whole
do.
problem
Yeah,
up.
it's going to be terrible. So what we're going to do is we're going to make sure that we type this into our calculator correctly, and we're going to learn that skill.
Can you show us how to do it
Yeah,
right here?
so
on
what
one
I
line?
do is I'm going to write this in a single line, this whole problem.
As if you were punching it in your calculator.
I'm going to type in the 15 first,
Okay.
and then I'm going to hit the times button. So
It's a
I'll
star.
use a little star for
Yeah,
times.
good.
And then notice there's a parenthesis right here. So you've got parentheses on your calculator. I'm going
Mm-hmm.
to put parenthesis there. This is actually kind of tricky. Can I borrow your blue for a
Sure.
second?
Yeah.
Every time you have a fraction, it's a grouping symbol. And you need to always put parentheses around the entire top and the entire
Good
bottom
tip.
of the fraction. So what I really have to do is put parenthesis, and then it's another parenthesis and another parenthesis,
Wow.
all together at once.
You're kind of going nuts with the parentheses,
Yeah,
Pete.
so
All right.
parenthesis, that's the blue one. And then I've got the black one. You always read fractions from the top to the bottom, so the top comes first. Then I have 1 plus 0.045. Fraction bar is a division, so divided by 52. Close that parenthesis to the 520th power. Usually
Sure,
there's
right?
a caret as a to the or an X to the Y button. To the 520th power.
Wow.
And then minus 1. I have to close the top of the fraction, that's the blue. And this is actually the end. I've got to do the bottom before I get to this one. So I'm going to now divide by.
That's this big division right here.
That's the division.
Good. Okay.
And then we've got a left parenthesis, 0.045 divided by 52. And I have to close the bottom. And then I have to close the entire fraction that's being multiplied by the 15.
Cool.
So that seems crazy and like a lot of work. I'm telling you, if you learn this skill, your answers are going to be more accurate. You're going to, it seems like it takes more time, but it doesn't. You're going to save time, and it's actually going to set you up for our Excel project later on.
I like that. That's so much easier than writing little numbers here and there and making mistakes along the way.
Yeah.
As long as you do this correctly, you're going to kill it in one big shot. It's like eating a big burrito in one bite. That's a bad idea. But
my wife would say not to do that, but I think that's now making me hungry. So you can pause the video if you want to and type these keystrokes into your calculator, and it's just going to happen for you. But make sure you punch exactly these buttons. The other thing I would suggest is if you can get a graphing calculator, not even for the graphing capabilities, but for the eye capabilities of the bigger screen, it's a lot easier to type these things into a graphing calculator. So go to Craigslist, spend the $40 for a used TI-84, and it'll help you.
Absolutely.
Okay, I have a problem for you. It's from your homework, and I'm not actually going to do it for you, but I'm going to talk about it so that I can help you. So in this problem, it looks a little bit like the last problem we did. You have a formula. Right now, you don't know what these letters stand for, but that's okay. You're given some inputs. You're going to put that 2500 into R spot. That's easy enough. And the 0.075 is going to go in for Z. Find Q. Well, this problem isn't quite as easy as the last one. How come, Neal?
Well, this Q is like it's all trapped up inside there. I liked it better when what I was trying to find was all alone.
Yeah, this equation is not solved for Q. And so to untrap it, what we have to do is undo what's being done, which is kind of serious looking. But I think a lot of times what people do is they just start doing stuff. They just start writing things down. It's flippant. It's haphazard. It's not well thought out. And a lot of times what I do is I say, well, what's my solving plan? Like, what could I do to make things a little bit better? If there's a 2500 here and then it's being multiplied by all the rest of this, hey, why don't I just divide both sides by 2500? That seems like a good idea.
Sure.
And then what I'll do is I'll maybe just kind of like cover it up with my hand and say, well, I know how to do that. Now what's next? Well, this is going to be 1 plus 0.075. So that's just a number right there.
Right.
And everything else is being divided by that number. So, boy, if I just multiplied both sides by that number, of course, that's the rules. You always do the same thing.
That's gone now.
Now that's gone. Now this is looking a lot easier.
Yeah, I can do this.
I've solved these before. Then I could just subtract 100, right? And that would go away.
That's gone. We
And
need more
then
hands.
we divide by negative 0.06. So
Four
I think sometimes instead of jumping into the problem, you need to just look at it and think about it and make a plan, and then executing that plan becomes a lot easier. But remember to think about opposites and covering up the things that you know how to eliminate, so what's left looks a lot simpler.
I also noticed, Pete, that you took things away from the Q kind of in the order of their distance from Q,
Yeah.
right?
Yeah, I think that's fair.
0.06 was the closest thing to Q, and that came off last. This was the next closest, the third closest, and fourth closest. It's kind of like getting undressed. Like you don't want to take your underwear off first. I've never tried that, but I don't think it would work very well, right? You got to take your coat off. Yeah. So that's the method that we're going to use to solve their homework, and you have a bunch of exercises to tackle now.
Sure.
We're here to
This
help.
should be familiar, but if you're having trouble, don't hesitate to come in and see us. We'd love to help you. We'd love to get to know you.
This is the time in the semester if you're having difficulties in algebra. Let's just face them head on. Come see us. We'll get them wired, and you'll be ready for the rest of the semester.